Okay, this is Math 2, Unit 9, Lesson 5. It's our last lesson for this unit. Looking today at numbers 13, 16, and I believe number 23, but for some reason it says 27. Maybe because this is 22, 23, 24, 25. I'm not sure. That doesn't still make sense. I have 27 right there, but I believe it's number 23. But however yours looks, we're doing that one. So one word problem. For today's lesson, if I'm not mistaken, I do not believe we're doing any surface area. For your unit, you're focused mostly on the volumes of spheres, not the surface area. So that means that essentially this first number 1 through 12 we're not worried about. I'm not worried about that at all. And we just come down here with a few problems dealing with the volume of spheres. The volume of spheres, the formula for that is the volume is going to equal to 4/3 times pi times the radius cubed. And that's our basic formula that we're working with today for these problems. So when we look at number 13, it's kind of a plug things in here. They already wrote down your formula there, and they want you transferring it over. In this case here, our radius is 6. So to solve this here, we do 4/3 times pi times 6 cubed. Okay? So to solve this with your calculator, maybe this might be most helpful for you actually. I'm going to go ahead and start with my 6, and I push the 6 button. And then if I press this little up arrow just below the pi sign, that's going to mean 6 to the 3rd power. Alright, so it's going to a little caret thing. I'm going to insert above. So 6 to the 3rd power. Oops, sorry, I can't see my fingers there. Apologize. Let me back up, clear it real quick. So we're doing 6. And I do the little arrow key. It's going to put an up thing right below the pi, 6 to the 3rd, and that's going to be equal to 216, which is what that number is. So that's 216, just so we have it in mind. And I'm going to go ahead and continue. What I do is I take that number and I multiply it by 4 and then divide by 3. Okay? So I'll do 216 times 4 divided by 3. And that gives me 288 pi. 288 pi to start off with. That's in terms of pi. To solve it in terms of just like the whole thing, I do 208 and I can go times, and I just click my pi button. I kept doing 3.14 my last lesson, and I got my answers wrong a little bit, so I'm going to go and use the pi button and say equals, and that comes out to 904.77, which I'm sure I'm going to need to round up to 905. Okay, and these happen to be millimeters squared. So I can do 288 pi millimeters squared, or if I solve it out, 905 millimeters squared. Both of those are the right answer because they want it both ways. Let's take a look at number 16 next. 16. Same formula, except I just wanted to look at this one because it gave you a diameter this time, not a radius. Remember, diameter, it's a radius and another radius together to make a diameter. So the radius is actually going to be equal to half of that. 36 divided by 2 is 18. So make sure you pay attention to your pictures to know what you're working with. Now I can go back and use my formula, and volume is going to equal 4/3 pi times the radius cubed. Alright, so back to the calculator once again. I'm going to go ahead and start with my 18, use my little up arrow to go to the 3rd power, 18 to the 3rd power, times 4 divided by 3, and go ahead and get that equal, and that's going to equal, to start off with, 7,776 pi centimeters cubed. So that's in terms of pi. To solve it in terms of not pi, so get pi out of there, I'll multiply that by pi, and I end up with 24,429 centimeters cubed. So those are my two answers for that problem right there. Alright, again, the only trick was take your diameter, make it into a radius. Let's look at the last one here. Again, a lot of these are surface area, which is why I'm skipping them. This is there's the volume, find the surface areas. We don't need to worry about surface area there. I have some more things dealing with surface area. Your teacher may have ones to do there. I'm not sure. I'm going to go and look at number 27 because it just looked like fun to me. So here we go. We have a bowling ball with a diameter of 8.5. Again, remember, a diameter is not a radius. That means I have a radius of half of that. Half of 8.5 is 4.25. So that's the number I'm going to be working with when I go to plug in my formula. All right? So my formula for a bowling ball, for the volume of this bowling ball, is volume equals 4/3 pi and then r cubed. So we have 4/3 times pi times 4.25 cubed. Now this is just to find the volume. The overall problem wants me to find this density quotient, which will be the weight, which is here, divided by the volume. So when I'm all done with the volume, I'm going to do 16 divided by my volume, and that's the answer I'm actually trying to find out right now. But for now, let's find the volume. So I'm going to go ahead and use my calculator again. And I'm going to start with my 4.25. 4.25. I'll use my little up arrow to make that to the third power. Multiply that by 4 times 4. All of that then would be divided by 3. And then all of that would be multiplied, because I want a real number this time, by pi. There's my pi. So I went this way and around and back, and I end up with 321.55. And that's my volume, and that'd be inches cubed. So now to find out what this density quotient is, I'm going to take 16 pounds divided by 321, I'll make it a little cursive L, that'll be 321.55 inches cubed. And so 16 divided by 321.55 comes up with 0.049. It wants it to the nearest hundredth. So this is my tenths, my hundredths. So I look next door, and that means round it up. So I'm going to end up with 0.05, and my units would actually be pounds per inches cubed. And that's my density. So the volume is here, 321, but my density quotient is going to be 0.05. All right, that's all we got for the day. Nice and short. Good luck.